Method number 3 for graphing linear functions, which I personally feel is the easiest way if your equation's in a nice form, is graphing using the slope and y-intercept. Now, let's make sure we take good notes and review something very, very important. Linear function form, which more commonly is called slope-intercept form, which is what the terminology will be on your tests and all standardized college entrance exams. Linear function form is y equals mx plus b. That's called slope-intercept form. Now, as we're already studying and learning this year, y can be replaced with f of x for function of x, which is equal to mx plus b. In either case, both of them are the same. From your prior studies on linear equations back in 8th and 9th grade, I all hope that you remember that m is the slope and the b value is the y-intercept. Thus, its name, slope-intercept form, because the equation is written in a form where you can just automatically see the slope and the y-intercept. Now, you're going to see the equations written a lot of different ways, but you need to try and put the equation into y equals mx plus b, and remember the slope is the number times by the x all the time. So, let's use that to graph. So I want to graph 3x plus y equals 5. Right now, this equation is actually written in standard form, which is the form ax plus by equals c. I want it in slope-intercept form. So, to put an equation in slope-intercept form, we need to do one thing: solve for y. And so that's what I'm going to do right now. I'm going to take my green pen and I'm going to take 3x plus y equals 5. And I'm going to draw the balance scale line. I need to get that 3x to the other side so that the y is by itself, so it's in slope-intercept form. So very simply, what I'm going to do is I'm going to minus 3x from both sides, because these will cancel out, and I have y equals, and I'll put the mx part first, which is negative 3x, and then the plus 5, and now I have it written in slope-intercept form. Now, when you graph an equation in slope-intercept form, step number 1, graph the y-intercept value. Our y-intercept value is 5. So therefore, on the y-axis, I go up to 5, 1, 2, 3, 4, 5, and I put a dot. Okay? Now, the slope is that number right there, negative 3. To make it a fraction, I put it over 1. And step 2 is use the slope to plot other points. Now, since the slope is negative 3 over 1, we all know slope is rise over run. So therefore, what I'm going to do, I'm going to start at my point right here, and I am going to go to the right 1 and then down 3. So I go over 1 and then down 1, 2, 3. That's the next point on my line. And I'm going to do it again because, as I mentioned in an earlier video, we need 3 or 4 points to graph. So I'm going to go over 1 and down 1, 2, 3. And I'm going to do it again, over 1 and down 1, 2, 3. And therefore, I have the graph, and I put arrows at the end. That's the graph of this particular function. And that's how you graph using slope and y-intercept. Example number 2. Let's graph this one. 3/2 y equals x minus 3. I'm going to rewrite the equation. And again, I need to solve for y. That means I got to get rid of the fraction 3/2. And if you recall from your earlier math career, it's times. So to get rid of this fraction, I invert and multiply, because the 2's will cancel and the 3's will cancel, and I get y left over. But if I do that on the left side of my line, I need to put this in parentheses and also multiply the entire right side by 2/3, which means I need to distribute. 2/3 times x is 2/3 x, and 2/3 times -3 is going to actually turn out to be -2. And there is my same equation, the same equation as this one, written in slope-intercept form. So as I mentioned, the first thing we do is we plot the y-intercept. On the y-axis, I'm going to put a dot at -2, because that is my y-intercept. And I see my slope is 2/3, which is rise over run. So therefore, what I'm going to do from this dot that I've already plotted, my y-intercept, I'm going to run 3, which is 3 to the right, and then rise +2. So I'm going to go over 1, 2, 3, and rise 1, 2, put a dot. Go over 1, 2, 3, go up 1, 2, put a dot. And I've got my 3 points on my line, and there is the graph of this linear function using slope and y-intercept. All right, one more. Now I'd like you to practice. Here's your problem. I want you to graph 5x equals 15y plus 30, and make yourself a nice, neat graph. And then the first thing you need to do is pause the video and solve that equation for y. All right. If I take 5x equals 15y plus 30, actually what I'm going to do, I always personally like the y on the left side of the equal sign, so it's in the form y equals mx plus b. So I'm just going to switch this whole thing around. 15y plus 30 equals 5x. Very good. So I solve this for y. So I'm going to minus 30 to begin with from both sides. And I'm going to rewrite this. Those cancel out, and I get 15y equals 5x minus 30. And then the last thing I'm going to do is I'm going to divide each number. Whenever you divide by a number, y, that's times by y, divide each number in the equation by 15. So I divide the slope by 15. I divide the y-intercept by 15. These will cancel, and I get y equals 5 over 15 reduces to 1/3 x minus, and 30 divided by 15 is 2. And therefore, I have my equation in slope-intercept form. Now, I plot the y-intercept, -2. Put a dot right there. My slope is 1/3, which is rise over run. So therefore, I'm going to run 3, 1, 2, 3. I always run to the right, and then I go up 1, and I put a dot. And then I run 1, 2, 3. I go up 1, put a dot. There's my 3 dots on my line, my 3 points. And there is the linear graph of 5x equals 15y plus 30. And that is how you solve and graph an equation in slope-intercept form.